We look at the latches like this. We have two ANDs, R and S, and with two NOR gates, and a clock level connected to this is the enable. Enable means when the latch is enabled, always gives in 1. R can be 0 or 1, S can be 0 or 1. Input of this is connected to this. This gives us a state, output of this rather, this output of this gives us a state qt, that is the state at that point of time t. And there is another one qt dash, it is the opposite state given at that time, not opposite state but another state corresponding to this, that is coming out of the uh, latch at this point of time. So it is called qt dash, and this one is connected to this. And this one on the other hand is connected to this, a second input. This one on the other hand is connected to this as a second input. So this is actually the feeding in of qt dash at qt at time t, and this is the feeding in of qt at time t. This is your set reset latch. It is used for setting and resetting. Okay, so let's ignore this. This was setting and resetting, that's why it's called set reset latch. So what happens if R is 1, reset is 1, reset. If R is 1 and set is 0, this comes out as 1, this comes out as 0, okay. And because of the inherent sort of nature of the NOR gates, so this resetting will come out as 0 and the qt dash will come out as 1. Can be seen the truth table that you see here, that qt plus 1, that is what is coming out of here, that will be 0. The qt dash is not read, so we will not consider that, but it is fed into here. On the other hand, if this is a 0 and this is a 1, opposite thing happens. This gives us a 1 and this becomes a 0, but obviously we are not going to consider this except that it is being set here. This gives a 1, and so this qt dash will be 1. So we are reading this. Now when you are using this set reset latch to setting or resetting something, what does it actually mean? Setting something means setting it to 1, resetting something means resetting it to 0. So when the 0 is reset is 1, that means you set it to, that means it's an indication that resetting is enabled. This is 0, should come out as 0. When setting is enabled, that is if this is 1 and resetting is 0, then obviously this will come out as 1. So the device will be set. Set means setting to 1. Set obviously means setting to 1. In the binary context, setting means setting to 1, resetting means directly to 0. This is how the set reset latch is working. Here both set and reset are 0, that means no signal is given, nothing is enabled. Then whatever the output was, if it is 1, it will remain 1. If it is 0, it will remain 0. So at t, whatever the output was, t plus 1 also the output will be the same. That means Whatever was the previous state, that will continue if S and R are 0. Only when it is changing, and you can see the signals are changing. On the other hand, if both of these are 1, it doesn't make any sense, so it is undefined. In fact, circuit is built in such a way, if it is 1 and 1, it will be undefined. So how does it make sense? Well, because you see, you either reset it or you set it. Reset it means setting it to 0, and setting means setting it to 1. So either you reset it, it's a double, it basically can be, it's a binary value. It can be 0 or 1, not together, not 1 or 0 together. You cannot be 0 or 1 together, right? So if you just put reset and S both as 1, doesn't make any sense, and the result obviously will be undefined as per the circuit itself. A modification of that is the data latch. It is a memory element. It is another memory element. But what happens is, in this case, the construction is more or less the same, except that the input, that is D, it is the data input. It is brought into the second AND gate, and then it is knotted and put into the first AND gate. So instead of 2 inputs, we have 1 input, which is the data input, and this together is one data element, just an element of a bit, just a bit is there, that is for just a bit, 1 0 or a 1. So, and it is put through an inverter gate, that is a NOT gate, and put it as an input to the first AND gate. So you see, when D is 0, S equal to 0 and R equals to 1, just like before. So QT plus 1 is 0. So basically, if you input 0, you get a 0. If D is 1, it implies that S is 1 and R becomes 0. So obviously that means Qt plus 1 is 1, irrespective of the present state. Both of these are irrespective of Qt, irrespective of the present state. The next state will either be 0 or 1. So, and this corresponds to the input D. If D is 0, you get an output of 0. If D is 1, you get an output of 1. So nothing but a data latch, because whatever data you put in, whatever data you are putting in, as long as it is enabled with 1, whatever data you are putting in, you will receive that at the output end. Put a 0, you get a 0, put a 1, you get a 1. So that means it is akin to storing it in memory. So this is how the D latch works.